Now integration by parts. We will try to take one more type of solving or way of solving integration, and if u and v are any two differentiable functions of a given variable, then if you take d by dx of uv, it will be nothing but u dv by dx plus v du by dx, you know already. U into v, first we take u out, then differentiate v, then du by dx. Okay, and let us integrate both sides. This gets cancelled because they are inverse, and put it like this. Now take this u here. So what do you get? uv minus, take this here to solve this. So take this one on the left side and this one here, so that uv minus integration of v du by dx. But let us take u equal to fx, this one, and dv by dx as gx. dv by dx, this dv by dx as gx, this one. U is fx, dv by dx is gx. So for du by dx will be what? F dash x. And what will be integration of this one? This gets cancelled, so only v, then you get integration of gx dx. Now, this can be rewritten as, because there are two functions different, fx, gx you have to find. This can be written as fx integration of gx dx, and then minus integration. I am just putting these values. Only these values I am putting here. So fx, this c, this is nothing but u is what? Fx. So this is u. U is fx. V is what? V is integration of gx dx. This is v minus integration of v. What was v? V is nothing but integration of gx. This is v. And what is du by dx? This is f dash x. And then dx remains f dash x. So this can be a idea or a technique to solve integration of two functions together. So what you get here? We are just taking it here, and we are just taking it here. So this will be f dash x and gx dx. So this way we are going to integrate. If you don't understand, don't worry about this. There is a simple explanation for this. The integration of product of two function will be, you write first function, then integrate the second one, then subtract the integral of what? Differential coefficient of the first function, and then multiply it with the integration of the second function. For example, x cos x dx. We'll take fx x, this is the first function, cos x as the second function. So x cos x will be simply x integration of cos x minus differentiation of x integration of cos x dx. You get x cos x is sin x, then integration of, because d by dx is 1, so integration of cos x is sin x. So again you have to, because there are two integrals. So cos x is sin x and integration of sin x is cos x. Okay, this cos x is actually the integration of this. So fx, this is okay, right? You can easily find out. But what if I take cos x as first function and x as second function? So let us try it. Cos x integration of x dx, then integration of d by dx of cos x, integration of x, that is this function, dx and dx. So you get cos x and x square by 2, d by dx of cos x is sin x is x square by 2. Now again, rather than solving, we have created one more integration. So we have two functions again, so we have to solve it. So this I explained because there has to be a proper choice of which function you have to take first and which function you have to go for the second. You cannot just do this, otherwise you will land up with another integration that you would have to solve again. So this is the best way of taking the first as x and second as cos x. And let me mention that this integration part by parts is not applicable for all the cases. If you have, say, root x sin x dx, this cannot be solved by integration by parts, because there does not exist any function whose derivative is this. There is no derivative. So how can you find out the integration of this? And while we are doing the integral, we did not add any constant of integration, as you saw, because if we add the constant of integration, if you rewrite the second function cos x as just sin x plus k like this, see, so even if you have any constant, it will be this constant if you added, so it will already be a superfluous. The second function will have a constant that will be superfluous. So the final result is concerned while applying the method of integration by parts, and this simply shows that adding a constant to the integration of the second function will be not worthy. And if any function is a power of x, it is a polynomial in x. So we take it as the first function always. In the case of other function like inverse trigonometric function or log, we take them as, if you have inverse trigonometric or log, you take them first. If you have x or polynomial, you take them first. For example, integration of log x dx is nothing but you take 1 here, 1 into log x. So this is nothing but log x dot 1. And I just said that if you have log and trigonometric function, you take them as first function. So log x integration of this one, then dy dx of log x integration of this one. So log x, this integration is x, dy dx of log x is 1 by x, and this is x. So this gets cancelled and you get integration of dx, that is x. Integration of x e to the power x dx. Here we have to take the function, because this I have already told x or polynomial type, you will take that as the first function. So x as the first function, e to the power x is the second function. So this will be x. Integration of e to the power x is what? Same. Then integration of the differentiation of x, that is 1. Then again integration of ex is e to the power x only. And this gets e to the power x dx, that is again e to the power x. You have to find this. So now you have a trigonometric function. So trigonometric function has to be taken as the first function always. So sin inverse x will be taken as first function, and x by under root 1 minus x square will be taken as second function. First we find the integral of the second function, because we have to use it directly there. So integration, let us find out the integration of this, because we will be using it in the part, we have to find it beforehand. So if you take 1 minus x square as t, the above one, that is x dx, you get as dt. So you can just write x dx as dt by 2 minus dt by 2. So what we have done here is, this is minus dt by 2 and this is root t, because t has been taken as 1 minus x square. So this integration is simple root t, right? And 2 gets cancelled because root half power will come. So this gets cancelled. It will be only minus under root 1 minus x square. So the integration of this is minus under root 1 minus x square, because t was 1 minus x square. Now you can integrate it by parts. Take this as first function, then integration of this function, then again integration of this and d by dx of this. This is d by dx of sin inverse x, that is 1 by under root 1 minus x square, and integration of this we have already got. You see that this gets cancelled and you will only be left with dx, that is only x will be the integration. First part will remain like this. So this will be the final result. Then e to the power x sin x dx. Here, because we have exponent and sine function, so we'll take exponent as the first function, sin x as the second function. So when we integrate, you see what will happen here. When we integrate, we'll take ex, sin x is minus cos x, plus integration e to the power x cos x dx by integration by parts. But we see that when we integrate it, we have got e to the power x cos x dx. This we have just got. So taking now, again integrating this one, we take cos x as the ex as the first function, cos x as the second function. So what you get? Ex sin x minus integration of ex sin x dx. We are integrating now this. But this was what? This was initial only, I. This was I. So you can place I here. And I can be taken here. So this will be 2i. You get the solution of this. You just have to divide this. And there is only one thing pending, which is integration. This integration of ex sin x dx, we just pending. You have to take this 2 in the denominator. So this will be the solution. Integration of this type, e to the power x fx f dash x. So if you get this, you can directly answer it. It's quite easy. If you take integration of this and integration of this can be taken separately, and this will be I1, this will be I1, this will be I2. Now take in this fx and ex as the first function, fx as the first function, and e to the power x is second function. So what you get this in this I1 will be fx ex, because integration of this is same. Then integration of f dash x e to the power x dx. Now you have to substitute I1 here. What you get? E to the power fx minus of this plus of this. So what you get? You can get those two values which are of opposite sides, so you can just cancel it. So ultimately the integration becomes e to the power x fx. So this is the simplest solution by doing this. So if you have a function like this, you can easily write the answer as e to the power s fx plus constant. So if a function like this, see, this is fx, this is f dash x. So this is fx, tan inverse x, f dash x is 1 by 1 plus x square, because the differentiation of tan inverse x is nothing but 1 by 1 plus x square. So this is of this form. So you can simply write e to the power x tan inverse x as the answer. How about this? Let us make it in that form. So x square plus 1, we can add 1 and subtract 1. Right? Just to make it simpler. Now you take this out and this out. This is first one, this is second one. And we see here that if this can be written as x minus 1, x plus 1. X plus 1 gets cancelled, so it is x minus 1 by x plus 1 plus 2 by x plus 1 whole square. Now this is fx, but if you differentiate it, you will get this only 2 by x plus 1 whole square. So this is of the form e to the power x fx plus f dash x. So what you get? You can simply write e to the power x fx, that is x plus 1, x minus 1 by x plus 1. This is your solution.